Welcome, and thank you for joining this webinar, Invisible Power, Infinite Scale, How Ambient Energy is Pushing the Battery-Free IoT World, prepared by Alpert research team. This combination of near zero cost and zero maintenance must unlock some use cases that were just impossible before. Where is the most immediate impact?
Without a doubt, it's in logistics and supply chain. For years, we've been stuck tracking things at the pallet or the container level because individual trackers were too expensive. AIoT lets us jump to item-level tracking.
A tag on every single box of cereal.
Every box of cereal, every piece of fruit. Think about automated warehouses. You move from someone scanning a barcode to a system that knows the precise location of every single item all the time with 1 to 3 meter accuracy.
And for food safety, that's a game changer.
For food traceability and cold chain integrity, it's huge. You have an unbroken, auditable record of the temperature for every single case of produce. If there's a recall, you know exactly which batches were affected instantly.
What about in harsh industrial environments?
Industrial sites are terrible for batteries. Vibration, extreme heat, moving parts where you can't possibly send a person to do a replacement. AIoT devices thrive there because they're maintenance-free. You can embed a tiny sensor powered by the vibration of a machine directly onto a bearing. It can constantly report on its condition, letting you spot a problem weeks before a catastrophic failure. That saves a fortune in unplanned downtime.
For smart cities, it seems like the sheer density and longevity are the big advantages.
Cities need to deploy thousands of sensors and then forget about them for decades. AIoT is perfect for that. You can monitor air quality on a block-by-block basis, optimize trash collection because you know which bins are actually full.
And structural health.
Structural health monitoring is a huge one. You can embed these sensors directly into the concrete of a new bridge or building. Powered by ambient RF or solar, they can monitor stress and vibration for the entire life of the structure with zero human intervention. Let's look at the smart buildings and automation sector, including retail. How does AIoT change the economics inside a store?
The cost point allows for item-level visibility in retail. A classic example is the smart retail shelf. Tags embedded directly into product packaging can monitor inventory levels in real time, flag misplaced items, or even notify staff when a high-value item has been placed on the wrong shelf, all without requiring a complex, expensive, active RFID system. In smart homes and offices, simple battery-free sensors can be embedded ubiquitously to monitor temperature, light, and gas leaks, running off indoor light or ambient RF power. In healthcare, the drive is toward extreme miniaturization for wearable sensor networks and implantable medical devices. These systems require stringent energy efficiency to ensure long-term, non-invasive operation. In agriculture, the ability to deploy wide-area, low-cost sensors for environmental monitoring in massive greenhouses or fields, sometimes powered by soil thermal energy harvesting, significantly boosts yield and resource management. And in automotive, battery-free sensors for vehicle monitoring and V2X, or vehicle-to-everything, communication enhance safety and efficiency, reducing the maintenance burden on complex vehicle systems.
The common thread across all these applications is not just communication, but the transformation of previously passive physical assets into autonomous data generators. How is AIoT positioning itself for the road to 6G and the realization of ambient intelligence?
AIoT is not just a side project. It's viewed as an integral foundational component of the entire 6G ecosystem, targeting the IMT 2030 standards. The future vision, ambient intelligence, or AMI, relies on computation being embedded into every surface and object, reacting autonomously to its environment, and that requires energy autonomy.
And to manage that level of pervasive, intermittent data, AI and machine learning must be crucial.
AML is essential for optimizing the operational side, specifically energy-aware operations. We can't rely on simple static rules. Sophisticated models can be trained offline to forecast future energy harvesting availability, predicting light levels based on weather forecasts, or RF coverage based on known usage patterns and energy expenditure. This intelligence allows the devices to devise proactive, energy-neutral operations. We're seeing the rise of TinyML, computationally efficient ML algorithms tailored for those ultra-low-power microcontrollers, enabling local inference that reduces communication latency and transceiver energy consumption, keeping the device away for only the bare minimum time necessary. What are the key 6G technologies that are going to supercharge AIoT?
There are 3 main ones to watch. The first is Intelligent Reflecting Surfaces, or IRS.
Which are like smart mirrors for radio wave.
They can intelligently steer and focus radio signals to improve coverage and boost the power of those weak backscatter signals, making the whole system more reliable and efficient.
Number 2.
Non-terrestrial networks, or NTNs. This is your satellite and high-altitude platform communication. This is what gives AIoT truly global reach for monitoring remote farms or environmental sensors in the middle of the ocean.
And third is edge AI.
Pushing the AI processing even closer to the devices, maybe to the edge router or the base station. This minimizes latency and improves privacy, which is going to be critical when you have billions of these sensors everywhere. Let's recap the most significant remaining challenges that the industry has to solve today.
The first is the one we've hammered home: synchronization and range. The massive sampling frequency offset in the cheap RC oscillators requires incredibly complex digital signal processing on the reader side. While RTAS helps, this required complexity ultimately limits the number of devices that can be efficiently inventoried simultaneously by a single reader. What about the interference problem, specifically the near-far problem?
The near-far problem is a classic radio issue, but it's amplified for AIoT because the receivers are so simple and have such poor filtering. The problem is when a powerful device, like a regular smartphone, starts transmitting nearby. It completely saturates the tag's receiver. The network has to be smart about managing this, maybe by shifting the backscatter signal to a quieter adjacent frequency band.
Then the other big challenge you mentioned is the physics problem: charge delay ambiguity. How does this make it hard to pinpoint a device's location?
This is a huge hurdle for any application that needs accurate positioning. Most positioning systems use time of flight. They measure how long it takes for a signal to travel.
But with AIoT, there's an extra delay.
There's an extra unknown delay. The time the device needs to sit there and accumulate enough energy to send a reply. And from the reader's perspective, that charge delay looks exactly the same as propagation delay, the time the signal was actually in the air.
So it messes up your distance calculation?
Completely.
If we connect this to the bigger picture, the absolute strategic prerequisite is a commitment to an energy-first design approach. Energy constraints have to be embedded deeply into the application logic, the communication protocols, and the deployment strategy. The entire system must be designed from the ground up to inherently tolerate power intermittency and adapt dynamically to variable energy contexts. The system must prioritize survival over continuous performance.
That focus on energy-first design truly encapsulates the monumental paradigm shift we've explored today, moving from managed, battery-powered resources to autonomous, self-sustaining entities. We've covered the dramatic economic and environmental drivers, the physics of harvesting and backscatter, the necessary intelligence of intermittent computing, and the global standardization effort across 3GPP and IEE. I think the key strategic takeaway is that shift in market dynamics. This technology fundamentally transforms what used to be an operational cost for a network operator, blasting out a radio signal, into a monetizable service, providing wireless power. This movement creates new ecosystems where the manufacturers and retailers who actually own the sensor data become the new data hubs. They create value in a way that's separate from just providing connectivity. It forces a total reassessment of where value lies in the entire IoT chain. Interested in gaining a deeper understanding of the transformative power of wireless technology? Join the Alpert research team's webinars to explore cutting-edge wireless innovations, their applications, and their implications. Click the links below to learn more.